Hello students, I am planning to upload a series of videos on the subject mechanics of solids. For any doubts, you can ask me in comments. Thank you.
So, mechanics of solids. Mechanics of solid is the study of forces acting on and within the solid bodies or material. Materials that we come across may be classified broadly as elastic, plastic, and rigid. Now, what are elastic, plastic, and rigid materials? Elastic material is the one which deforms under load or force but regains its original shape on removal of the load. That means when the load is removed, the deformation is completely disappeared. It regains its original shape and size. Such type of material are known as elastic material. Plastic material is the one which deforms under load and cannot regain its original shape on removal of the load. And lastly, rigid material is the one which do not deform, rather it breaks under load. So there are three types of materials, that is elastic material, plastic material, or rigid material. However, in practice there is no material which is purely elastic, plastic, or rigid. That means every material do possess all these three properties, that is elasticity, plasticity, and rigidity. Every material is elastic a little, plastic a little, and a bit rigid also. Therefore, it is considered that every material is elastic, plastic, and rigid within certain limits of load. Up to some limit, the material is elastic. Up to some limit of load, the material behaves like a plastic material. And then, with excessive load, it breaks. That is, it becomes rigid. Generally, we handle a member in its elastic range. Structural members are all designed so as to remain in the elastic condition under the action of the working load. That means we use the material in its elastic range, because if you use the material beyond its elastic limit, if you apply load beyond its elastic limit, the material will undergo plastic deformation, which is a permanent deformation. The deformation will not be removed or disappear after the use of the material. Then what happens? The material is completely useless, become for the future use. It cannot be repeatedly used. So for repeated use of the material, we should use the material within its elastic limit, and when all the work is over, the material again becomes its original shape and size. Now, simple stress and strain. What is simple stress and simple strain? When a member is loaded, the cohesive force between the molecules within the body offer resistance to the deformation. This force of resistance offered by the body against deformation per unit area of cross-section is called the stress. The load is applied on the body while the stress is induced within the body. So stress is a thing which is developed within the body, inside the body, and the load is applied from the outside. Now, consider a member of length L and area of cross-section A is subjected to a load capital P as shown. See, this is a member, length is L, the area of cross section is A, and suppose it is applied or subjected to a load P, capital P. We will denote load as capital P. Now this load, the intention of the load is to pull the material out or elongate the material. So such type of load will be called tensile load. If the member is under tensile load, in every cross section, what happens is within the material, at every section, if you look into the section, such type of things are supposed to be developed. So these are called stresses. And the total stress combinedly make a force R. This R opposes the P. That means the intention, the P is to elongate the body, and R is the resistance which opposes the elongation, opposes the P. So R has to be equal and opposite to P. And this R per unit area, which is these small arrows, are called stresses. This is called simple stress. So if the member is loaded, so within the body there are things like this which are called stresses. These are simple stresses. These are sigmas. So the load is called, now such type of load is called tensile load, as it tends to elongate the body. At any cross section XX within the member, the resistance to deformation is R, which is equal to and opposite to the capital P load. As defined earlier, stress is the resistance per unit area, and if stress is denoted as sigma or small p, then sigma will be equal to resistance per unit area, because resistance is equal to the applied load, so we can say sigma is equal to P by area. And the unit of stress will be kilonewton per meter square, because it is load per area. Load is kilonewton, area is in meter square or centimeter square or millimeter square. Load will be in terms of kilonewton, tons, kg or anything. So the unit of stress will be kilonewton per meter square, for example, so to say. Now this is simple stress. Now what is simple strain? Strain is defined as the ratio between change in the dimension per unit original dimension of the body and symbolized as E, small e. Stress is sigma E, sigma, and strain is small e. In the above case, let the change in length is L. Let the change in length L of the member is dl. Then strain will be increase in length by original length, that is small e is equal to dl by L. And such strain is called tensile strain because it is due to the tensile load. The load WP has elongated it, and the elongation is dl, so the strain is dl by L, and it is because of the tensile load, so the name of the strain will be tensile strain. Similarly, what are the types of stress? Let us see. Depending upon the type of loading and consequent deformation, the stresses and strains are: number one, it can be tensile load, if the load is tensile, or direct load. When the load intends to elongate the member, it is called the tensile load. The stress is called tensile stress, and the strain is called tensile strain. So this is one type of stress and strain. If the load is tensile, the stress will be tensile stress, the strain will be tensile strain. And this tensile stress is also called direct load. The tensile load is also called direct load because it is applied directly or normal to the cross section and axially along the axis of the member. So it is also called direct load or axial load. On the other hand, there is also compressive load. If the member is subjected to a load such that it intends to compress the body, when the load intends to compress the member, the length is decreased by dl. See, the length will be decreased from here to here. Total was L. Now it has been reduced by delta L. So compressive stress is sigma is equal to P by A. Here also load by area. Stress is as usual sigma, but only the name will be changed. It will be called compressive because the load is compressive. And compressive strain, add the usual formula, small e dl by L. Here only it will be called strain, but compressive strain because the dl is not elongation, it is a compression. So sigma is P by A, small e is dl by L in both the case of tensile and compressive loads. Here only the name will be compressive stress, it will be tensile compressive strain. And the earlier was tensile stress and tensile strain. Well, now the third type of shear stress, third type of load, which is due to the third type of loading, that is shear load. Shear load, how it is applied? See, if it is a block, if the load is applied not normal, perpendicular to the surface, but tangential to the surface. If the load is tangential to the face of the block, the body will deform like this. A, B, C, D will become A1, B1, C, D1. Okay. Now this deformation is the B will be moved to B dash and the angle will be phi. So when the load is tangential to the member, the shear stress will be tau P by area of the surface on which the load is tangential. Shear strain will be that angle phi because phi radian, because tan phi is BB dash, deformation by original length. So deformation is BB dash, for original length is BC. This by this is equal to tan phi, and for small angle tan phi, phi radian will be equal to tan phi. So we call it shear strain should be tan phi. It will be denoted as phi. For small angle, phi is equal to tan phi. Okay. Now these are the three types of stresses. We'll be discussing in the next video what are elastic limits and Young-Hooke's law. All these things will be discussed in our next coming videos. Right? Thank you.